So, hi, welcome also from me to the Python Summit. I'm here to evangelize you all to the cult of Rust, or maybe just talk a little bit about it. I'm joking, of course, like there's a lot of good reasons to use different programming languages as well, like Python. But since this is the last Python summit, I can pretty much say whatever I want. And also, since we're a bit early on time, I hope I get through it. Yeah. So I want to take you on a bit of a journey of my programming life. I've been programming for almost 20 years now, and it's been a fun ride. I would say, especially like the early years where I didn't program professionally have been very fun because I got to do things like the Mandelbrot and like other fun things. I eventually wrote a video game. It did work. It wasn't very pretty, but it was an ego shooter with network capabilities. I then forgot all about network again, and like I didn't know anymore what TCP was and UDP. And so a bit later, I started working at a company in PHP. That's why there's no slide, because I don't want to be proof that I work on PHP. But like, I mean, at least Danilo, who's working in the back there, knows how horrible it really was. And like, my code base especially, like I think I had like 1,000 lines of regex expressions that were then like put together in some ways and parsing something. Yeah, it wasn't good. But like, then I studied and I started a project called Jedi. Jedi autocompletion is something that you might be using, or you might be using PyCharm. It's pretty much either of the two, or it has been. Like nowadays, there's also in VS Code, there's a kind of a different engine. I'll talk about that a bit later. This was like 2012, and I've been doing this pretty much ever since. This is kind of an open source project. I then did like 3 years of like just open source work. Basically, I've had saved up some money, and like it was just kind of fun to do that. And as I said before, I kind of like doing things just because I like programming, and so I just didn't work at that time. I then went to Afghanistan, and I'm only telling you this because I needed some pretty pictures to calm you down if there's like ugly Rust stuff coming. And so during that time, I would say I was pretty religious when it comes to languages. Probably in life in general, I was pretty like strong-minded, but when it came to languages, I thought like Python was the greatest thing that's ever been invented. And nowadays, I'm like a bit more open-minded, I guess. There's a lot of good languages out there, a lot of good reasons to use one over another. Then obviously at some point, money started running out. And I was able to get some money for Jedi from like companies, but like it wasn't enough at all. So I joined a company called CloudScale. I'll mention this later a bit, but in general, this was it's a Python Django shop with a lot of React and Go. Or that's what I'm doing. We're not a Django shop. We're an infrastructure as a service company. But I'm like the 5th best programmer there. We're like 4 developers. So go figure. Nobody. If you want to work with us in general, just we also have system engineers and we have some network engineers. So feel free to contact me. We're always open to talk. So why Rust? Why did I think about that? Well, for me, like the main idea was to get like Jedi to a faster place, because like if you're typing in your IDE or your editor, you want to get auto-completions in a really fast manner. And like for some libraries like NumPy and others, it was just not fast enough, really, or it's still not fast enough, in my opinion. It's kind of, it works, but it's, yeah, it could be nicer. And like Rust is considered in general to be really fast, like 10 to 100 times faster in like those micro benchmarks. And I think this holds up pretty well for like larger programs as well, because in other languages like Java, where you have like a JIT or Go with garbage collection, like there's issues that like stop you from getting that speed up at a certain scale. But in Rust, there's not really, like Rust is just as fast as C basically. But like for the general world, the reason why they use Rust is because it's fast and it's memory safe. And for people who don't know what that means, is that like in C, if you write something, you just have pointers, and like those pointers can point anywhere, and pretty much if you make a mistake as a programmer somewhere, it will lead to memory bugs, and that leads to segmentation faults and other nasty things. In general, you could also say Mozilla, that's where Rust comes from, tried to make this language because they had issues in Firefox, like a lot of the security bugs you see out there are issues with unsafe programming languages. Yeah. So Rust doesn't have garbage collection, and how it does that we'll see later. So in general, the programming world loves Rust, like you hear it everywhere. This is also because it has like Python, it has a democratic kind of community, a good license, a friendly community. Rust has a really nice package manager called Cargo, which is like way better than pip, which is way better than npm. So, but like, yeah, and then there's these like surveys, and everybody loves Rust, and people don't love Python as much anymore, I guess. But this is mostly hype, because Python is still like the primary language in universities, and like Rust is a language that's barely used by anyone in a professional environment. It's mostly like people on GitHub and like missionaries. So, and I guess like people loved Python before they really used it. And I think this is a general trend, like people loved Go before they used it. And I kind of thought Go was a good language before I used it. I don't like it for, I think, good reasons. It's probably a good language for like big enterprise companies and like stuff like Kubernetes with an insanely huge code base, but not for like smaller projects, which I like to work, or like medium-sized projects, which I like to work on. And like even like languages like TypeScript, which to be fair is a pretty good language and like has very nice features. Like those languages are also hyped because nobody uses them, or like most companies started using TypeScript, but like all of the old code is still JavaScript, generally speaking. And then there's stuff like grep, which is like a really nice grep replacement, and so people just hype it up. But like, what is Rust? Why would you use it? The Rust book describes it as a programming language that helps you write a faster, more reliable software. And I think this is mostly true. Like the Rust language, it really like, I kind of covered the fast part, but like the type system really enables you to write reliable software. So, but let's kind of dive into it. I want to give you a quick overview over the language. this is gonna be very broad. There's lots of good tutorials out there, so feel free to check those out. This is just like a small introduction. So as a first example, I want to show you a function in Rust and Python that kind of looks the same. In Python, as you'll see, there's like the annotations I said there. If you don't know those annotations, as far as I know, there's going to be a talk about MyPy later. So you will understand what those are. But in general, like, it kind of looks similar. I had a few more examples that that didn't made it because of time reasons, because I didn't have time to show those. But there's a lot of such small examples you can show where the languages look very, very similar. Like there's braces there, but other than that, it's pretty much the same. There's no return in Rust. That's something special where you can just omit the return and just write your code a bit more compact, which is generally a very great concept that you'll learn if you ever write code in it. But and here kind of we get to the problem. This was the easy parts, and now we already get to the smart parts, because there's no there's a very small kind of set of the language that's very easy to use, and that's also kind of you can write a lot of code with it, but most code that you'll see is not that kind of easy. So one of the great things about Rust is macros. Macros are those things where it looks kind of like a function call, but it has an exclamation mark. So for now, just assume kind of those are functions, but it's a macro. It's kind of like what you have in C, but this is in Rust. You have hygienic macros, so there's a lot of advantages over C, and it's a really nice concept in general. So some of those macros are very simple, like to do or unreachable, which is raise not implemented error in Python, or the println macro, which is print in Python. And then there's fun stuff like debug, which is basically it lets you print the current line with the debug statement. So a times 2, and there's a +1, which is just a plus, it calculates a times 2 + 1, but it will print a times 2 and then equals 4. And in Python, you could also do this. You could just do a print there, but then you would just get 4 as an output. And I think this is kind of nice to debug Rust sometimes, especially if you don't use a debugger and you just want to have a quick output. So that's really cool. And there's other macros that are kind of cool. And it just enables you to, unlike a language like Go, for example, that is very verbose, you can just write those small things, which macros enables. So those are the simple data structures of Rust. There's really not more, I would say. And that's also kind of an easy part, I would say. Obviously, I wouldn't type datetime exactly like that in a real use case, but it does the job. Come on. And so the more a struct is basically a C struct. It's basically what if you've ever programmed C, it's what you would do there. It kind of reminds you of a data class in Python, but it has a more it's very small in memory. In Python, a data class still has a lot of overhead. Then there's an enum in Rust. This is I think one of the most brilliant concepts. It's not Rust invented this. This is very known in other languages as well. Swift has this as well, and I don't know where they stole it, but this is probably from the 90s or 80s somewhere. And so an enum is basically, you you know enums in Python maybe, so a value can be either a number, a string, or a null, kind of like a JSON value. And so but in Python, you couldn't attach a value to the number. In Python, it's just a number, a string, or a null. And here it's a number, and then you have like kind of, this number is a floating point number, and you get the number out of it. And so this kind of enum thinking enables a lot of stuff. Like Rust has generics, and so like these are like some of the generics you'll be using all the time. It's option and result. Option is basically either a null or in Python a none, and in Rust as well, or a sum or something. And this also kind of means, because we have option and result, we just return a result of something. And this means that we don't have error, like we don't have try catch or like the traditional object-oriented error handling. And so maybe hands up, who's using Python 3.10 already? That's few. That's almost more than I expected. So in Python 3.10, there's a new feature called match. And match is something that Rust also has. You'll see below that how the syntax kind of is in Python. You might be using it at some point in the future if you haven't already. In general, in Rust, it's kind of a bit nicer because the types, like, first of all, it lets you unpack enums. And as you can see up there, this is kind of the case where we have, first, we have a number. We want to say, so we get that kind of value thing. We say value, colon, number, and then we kind of get the number and return it. Or, and this is like kind of the last thing, this is like a wildcard match that also exists in Python, by the way. Or we just return none. So we kind of have our option. And then there's like a third thing there that I do there where I'm like printing a to-do. So why is a string coming here? So this will eventually lead to a traceback, and just like kind of nice to program this way. There's another like pattern matching kind of piece of code that I wanted to show you that kind of shows why pattern matching is so nice. This kind of thing also works in Python. What doesn't work in Python you cannot return a like in Python it's an expression, it's not a state. In Python it's a statement, not an expression. So in Rust it's an expression, and you can return values from inside. That's why I didn't like the Python proposal very much. Though, like, I don't want to blame them, because like Python just works very different as a language, in very different ways as a language, so that's kind of hard. So what we do here is we just, we have a list of strings or values, again, of those like JSON kind of type values. And so the first example is just, if it's empty, just print something. Then if the first value is a string and the string is hello, and the second string is world, then we say print hello world. And then we say if there's just any two values, we print them, both values. That's kind of the syntax in print lm to, like in Python, you can in kind of format strings as well. This is also very similar. Or we have it to do for all other cases. And so this is kind of how pattern matching works. If you don't know that kind of part, don't worry. But you can learn it for Python as well in the future. It's pretty nice. So let's get to the hard parts. And here is where we take a deep breath and we kind of look at the more annoying parts in Rust. So the first thing that I want to talk about is traits. Traits don't seem to be that hard. It's basically an interface for anybody who's worked with like Java or C# or whatever. In Python, there's kind of not really, like there are interfaces, like it's abstract base classes, but nobody really uses them. So, or maybe not nobody, I don't want to offend you, but you're probably the only person in the room. And so in Rust, like those look very simple at first, but there's just so many things that you'll stumble over, like associated types or generics or like lifetimes with like invariant variances, and they are just hard. Then one of the other things that are hard is creating macros. So if you say like if we write a macro here, say hello, and then below we just execute it. A macro basically is like in C, just a few commands that will get executed at, or like you can write pretty much anything there in println hello, and it will get executed where the macro is. Like this is good if you don't want to like deal with inlining and stuff, and you just want to say here execute all this stuff, and you don't have to duplicate code. But it's still pretty hard to write them. I always have to look, even though I wrote a lot of those macros, I always have to look up the syntax. Like this part is pretty easy, but there's like way more coming. Not in this talk, but like. So there's lifetimes, and ownership is really hard in Rust. I think it's some of the hardest like concepts to grasp. In general, like this piece of code looks very simple. It has references, which we haven't seen before, and references always carry lifetimes. Usually like Rust is able to figure them out, and like the compiler will say, oh yeah, this is fine, yeah, you can do it. But here, because you have two references in the input, Rust doesn't know what the output will be, and like this will result in like this weird error, and you're like, oh, what should I do? But like Rust is pretty cool because, and don't read the error, but Rust will tell you, oh yeah, you should probably do this. And most of the time it's correct. It's just that if your code gets more complicated, Rust will not be able to help you anymore. But like error messages in Rust are pretty good for simple things. It's just that for complicated things, they're horrible, and like you'll want to kill yourself. Like sometimes I'm just like 4 hours working on like why a lifetime is not the way it should be. And this is mostly because I work a lot with lifetimes when I program Rust, but yeah. It is what it is. The correct example looks like this, where you kind of have to specify a lifetime. It's with an apostrophe. But this kind of starts to look a bit unlike Python. It's kind of annoying already. I mean, but this is really what Rust boils down to. This is really what Rust is under the hood. It always has those lifetimes. It's just that most of the time you don't really have to specify them if you only use like one lifetime. So, and then you're like, okay, I want to understand Rust better. I try to look at ownership and lifetimes and how they all interact, and you land here. And you're like, what? Like this is just what, like in Python, this is just how you pass a value around, like how you pass a parameter around. But there's like different kinds of ownership with threads and allocations, and then there's also libraries that have even different ways. So we don't even look at this. I just wanted to show you how complicated it is. And again, now we're going to the insane parts of Rust. Again, Afghanistan, a deep breath, because it's not gonna get better. for parts here, I don't even have code examples because it's hard to show like the madness in its full glory. In general, I would say like, and I think this is something that most Rust devs would say, avoid unsafe. If I had time, I would let you recite a prayer, thou shalt not use unsafe, because unsafe makes like everything possible. It's pretty much like you can just write C now. You can like use pointers and whatever. And this is also part why the language is so powerful, because you can basically do anything, but it's also really hard. So I warned you. And then there's like certain bugs, and especially like around newer language features, and like this piece of code, I don't think anyone understands like in a quick way what that is. And what it is basically just passing in a closure and getting it out again and avoiding certain bugs. And this is like, but this is like what Rust is at a very, very high level, like low level. It's just lifetimes and generics and hard to understand. And this is just one of the bugs I created. And I think I've created like one or maybe two Python bugs in like 10 years. And it was more in libraries and not in the compiler. And here, because the Rust compiler is so complex and can do so many things, you'll just see issues. Though I have to say, if you use MyPy, which is also kind of a compiler for Python, there's also like a ton of bugs. And this kind of issue, which is like around closures and lifetimes in closures, also means that async is pretty hard because it works a lot with closures. And so that's that kind of thing. Another thing I found was like trait lifetimes that are bugged. We're not going to look into this, but it's like, it just showed me that it's hard. And then there's like kind of the fun stuff. I just wanted to show you this because it's really insane that you could do this. Because this executes Python inside of Rust. And and this is probably not the best idea. There's better ways to interact with Python in Rust. Like there's really good libraries. Just find tutorials about them. But so this basically what it does is it has a Python interpreter inside of the macro. And how it does that is kind of complicated to explain, but basically everything inside a macro is a token stream, and you can execute that in an external process. So inside of those braces, you can do pretty much whatever, except that the syntax, like the syntax tokens, have to kind of resemble Rust, or have to be Rust tokens, which is crazy, to be honest. And like, but since Rust and Python share like a lot of the tokens, you can just write Python in it. But this is, I think it also uses unstable Rust. So, and I'm definitely not recommending this. I'm just showing it to you because you can do it. So, but this leads me to like talking about, is Rust buggier than Python? I personally don't think so. It's just for like those like very kind of crazy features that most people don't use. I've like one of the organizers here, Dennis, who works with me, he has written some Rust code that's pretty easy to understand. It doesn't use lifetimes, it doesn't use macros, it doesn't use traits as far as I know. So he's avoided pretty much all of what I just showed you. So you can write pretty simple and like very readable code in Rust. It's just if your code base grows to a certain size, it's kind of hard. Python and Rust to me feel very stable. Like most languages I've used, except I think when I started writing some stuff in JavaScript in like 8 years ago, like in Node, it just would segfault. But like that's the only time I've ever had issues with languages in a big way. So now I want to talk a bit about certain case studies. It's mostly my experience. This was my alarm clock. This is when I normally get up. This is kind of my experience and why I chose Rust and went Python in certain cases. And I mean, to be honest, I couldn't choose Rust like 10 years ago because it just wasn't really a language at that time. But now it is, and I just want to talk about when to use which one. And no, none of those case studies is gonna cover the video game I wrote when I was like 18 years old, because that one is out of questions. So then I also want to mention I'm not kind of in the enterprise world at all. If you do enterprise software or anything like large scale, kind of things shift and suddenly like Go and Java become like kind of good languages because you can manage the complexity with a lot of devs in an organizational way, and the code bases don't become like those huge messes that they can become if you're not cautious with Python and Rust. Let's get into it. As a first case study, I want to talk about Jedi and MyPy in Rust. This is kind of, or Jedi in Rust, sorry. This is what I wrote like 10 years ago. I have been working on this for a long time. It's probably like 4 to 5 man-years now of my time. It's an open source alternative to PyCharm. There's plugins for all major editors, and I think VS Code has used it for a long time when they weren't able to write their own stuff. Now they use a different kind of thing for it, but it's called Pyrite, by the way, and that's pretty good. But I'm rewriting Jedi in Rust now, so that will be better. And it's also used in IPython and Jupyter Notebook. So if you use that, I'm pretty sure you are using it, and it's kind of pretty big. And at the time when I started, I just wanted to get it out as soon as possible, and that's also why Python was a great choice, because like Python is a great prototyping language. You can just get something done really quick. The long tail is different. There were a lot of issues. I was like, after 3 months, I had an auto-completion libraries, and then I spent like 8 years reworking and refactoring it. But it's still kind of amazing that you can like do kind of a complex piece of software in Python and just write that. I don't think that would have been possible in Rust. And if it took me like 2 years to have a first kind of user, open source user, I don't think I would have done it. So in general, Python is, however, a bad fit for Jedi or anything that looks like Jedi, because like Jedi is a CPU-bound process. Like it just has to parse things quick and has to use type inference, and it's just a bad fit. Python is good when it's like IO-bound problems in general. So, but that's kind of what I want to say here. So if you want to get it out, if you want to ship it early, it's kind of still good, but it wasn't good for this case. And that's what gets me into why I'm rewriting it. I want to rewrite Jedi and MyPy in Rust. I'm like passing like 1/5 of the MyPy tests now. This is not that much. It doesn't look that good, but it will get better, and it's really fast. It's like 20 times faster than MyPy at the moment in debug mode. And if you use it in release mode, I have like a 650 times speed up, and MyPy is still kind of optimized. So and that's like the tests are 650 times faster. I don't think like the whole thing will be 650 times faster. It's probably more like 10 to 100, but that's still like good, because if you run MyPy over a code base and it takes you a minute and now it takes you like 5 seconds, that's like a huge difference. And so that's my hope. It's not finished, it's not public, but do not underestimate me. I'll get there eventually. It's been like 2 years now, and it will take me at least like 2 or 3 more years. Maybe. And that's like software estimations, so it'll take probably longer. You all know what I'm talking about. And then I want to have a third case study of the company I work at, which is we wrote our control panel to start servers in Python and Django originally, and then we kind of did a refactor and wrote the front end in React, which is like are both great choices, I think, for what we're at. Like people sometimes say, oh, this is slow and maybe it's Python, and like it always turns out it's not really Python because it's all IO bound. It's always the database, it's queries that are slow, and like we're always limited by our services, because Python is not that fast, but it turns out for anything that's IO bound, it's just good. And like latencies could be a bit better probably without Python. It would probably not be like 120 milliseconds for a request, but it would be 100. But who cares really? And like if we have to scale it, we can just spin up another server. So that's like the cost of that is not that big, and I'm very much a proponent of saving energy, but yeah, like spinning up a server is like a few watts, because I'm not talking about like I'm just talking about a few processes. And like one of the reasons why Python was pretty much a great choice as well was because initially we had like 3 months to rewrite the whole thing in Python. It was written in Lua before, which is a very odd choice for kind of a bigger project, I think. And I would probably choose Rust now if I was there, but that would probably be a bad idea, because I don't think I would get it done in 3 months in Rust. Because in Rust, like you just write all that code, and then there's like to-dos in there, and it's kind of, it's just, I don't think it would be a good choice, even though I would probably choose Rust. But that's more because I'm like, I think Python's a great language, but I want to learn new stuff. And it's more coming from that angle and not from, oh, Rust would be a better fit. So yeah, now I want to summarize the whole thing. I want to say that Rust in general is an extremely well-designed language with an extremely well-designed type system. One of the advantages Rust has over a lot of other languages is they didn't go and make a language in like 6 days like JavaScript or even other languages that have been designed like by basically, like Python was designed by Guido, and like it's very well designed in a lot of ways, but Rust had like the advantage that they iterated over a lot of this syntax and like core features, and I think that's great. There's no garbage collection, memory safety, and performance is all great. We've talked about that. I think one of the big pluses for me personally is that when I think in Rust, I think about data structures. When I think in Python, I think about basically algorithms. I think in general, like good engineers should think more about data structures and less about algorithms, because algorithms are just like the juice in between, and data structures are how you should structure your application. And Python, I think, and this is really what what I was talking about, enums as well, kind of makes that hard. And I've always tried to urge certain core devs to introduce enums, but I don't think that will happen in the near future. So one of the things that's kind of neutral for me is that Rust is very strict. That's kind of in a type system, and it's very hard to test like smaller stuff. This cannot be. Oh, this is again the alarm clock. I'm not kidding. So Rust is very strict, and it's hard to test certain things if you just want to say, oh yeah, how about this? And like in Python, you would just like rewrite it a bit and like change the data structure, and it might crash in some places, but like you don't mind because you just want to test it. And for like that one niche case, and in Rust, it's like, oh, you have 200 errors now, and before you fix those, you don't get anywhere. And at the same time, you have those 200 errors and you know exactly where the issues are. And in Python, you don't. So that's just, I guess, an advantage and a disadvantage at times. I think Rust is very hard to read and learn, which is clearly a disadvantage, especially the hard to read part. I think it's kind of hard to read, even if you're pretty good at it, because there's so much you can do with it. Lifetimes and ownerships, I covered this, lead to unproductive days. I think there's like at least 10 days where I haven't done anything except like debugging lifetimes in the last 3 months. But I also have to say, I do like crazy lifetime stuff. I do like lifetime bounds with dependencies and stuff. So yeah, the mental model needed for stack and heap is pretty crazy. Yeah, you just kind of want to keep kind of this stuff in mind. This is a cheat sheet. I don't want to explain it now, but like this is what I always did in the beginning. There's like the other cheat sheet that I showed you as well here. So kind of memorize that stuff, and I hope you'll be fine, but it's not easy. Like but at the same time, we're all here to learn, and like if you like software development, like more complex stuff, this is really fun. It's just not the best business case all the time. But I don't really care about business cases, so yeah. So this is, I promise this is the last slide. In general, pick Rust for high performance, CPU memory bound problems. It's good for when you want to avoid bugs, especially memory bugs. And in general, I think you should have a team of very capable devs. If you don't, I don't think you should be using it because you'll get nowhere. That's a good thing about Rust. You'll just get nowhere. It won't be shit. It's just you won't ship software. And you basically, one of the advantages as well is you just get one binary. And in Python, it's just a lot of dependencies and files that are like the Python release process is pretty annoying. Python, on the opposite hand, is for data science, AI. It's an extremely good choice, I think. Still, Rust is not anywhere in those areas. And I don't think it will be, because most people that use data science are people that want to like hack something together quickly. And that's just not what Rust is, I think. And they don't want to understand a complex language. That's also not why C++ didn't win at all in that kind of category. Like high performance computing is a different kind of beast, but yeah. So for prototypes, Python's great. If you have a team of average devs, if you have like bad devs, I don't think Python's a great language, because there's like, if you have like a lot of juniors and like people that don't understand the language, they'll do horrible things, and they'll use meta classes and like weird global state. And I think at that point, just use Java and you'll be fine. And I think like one of the big advantages of Python as well is it's very hackable and debuggable. You can just at any point like start PDBE or hack something together. You can modify any global state, which is a very big danger sign if you ever do it. But it's very valuable if you want to ship something. And with really good, in the Rust case, I mean like really good type system experience as well, not just a very capable dev in another language. So I think this has been my talk. Are there maybe any questions? I don't know if we do questions, we can, but... and I want to say one more thing, since this is the last Python Summit, I want to say a huge shout out to the people organizing this. It's been a blast all these years. It's kind of sad that it ends, but it's also, we've had a good run. I especially want to thank Danilo, who started this thing, I think, Dennis and Samuele for for doing the huge amount of work. And yeah, maybe let's clap for them.
Thank you, Dave. Questions? Any questions? We have a mic runner. It's going to get to you eventually. It's right behind.
Thank you. So a few years ago, I tried to play a little bit with Rust because all the security people seem to love it because it's a safe language and you avoid all those buffer overflows and stuff like that. So I tried to install it, and there was no package for it. There was no package in whatever distribution I was using at the time. So I went to the Rust website and looked for the recommended way of installing Rust.
Yeah.
And it's car pipe bash.
Yeah.
And I was like, do security people really love this?
Yeah, see, I'm not a system engineer. I'm an engineer. So that's what system engineers hate. I don't hate that. I'm like used to it now. No, but you're right. Like this is pretty, like it's obviously pretty bad, but like I think it's where we are at the moment because Rust is also pretty new, and I think once things stabilize, we'll get better.
Right. That was the question I wanted to ask. Do you think it will?
I hope it will get better, but I also think like it's the same issue. Like we're also in our company kind of in a process of not always using upstream Python of like the operating system and like using Docker instead, because you can just use newer versions because we're on an older system and we're using Python 3.6, and I would like to use the newer Python features as well. So it's kind of that issue as well.
Thank you.
Other questions?
Since you did JEDI in Python and in Rust now, could you sort of give an indication of the number of lines of code? Would it grow massively or stay more or less the same?
That's interesting, actually. I think it's more or less the same. It's probably a bit more in Rust, but also because of the braces that you have. So that just kind of creates a lot of space. But it's not like a Java or something where you have a lot of kind of dead code that doesn't do anything. It's very expressive still, but sometimes I would say it's kind of the same if you do Python with annotations. Mm-hmm. Because in Python, if you write annotations, you also use a bit more space, and so it's kind of at that level, I would say.
Thank you.
Maybe a bit more, but not. It's not like.
I have a question back here, and I have the mic, so I can ask it. Here.
Oh, yeah.
So you said that you would recommend Python for average devs and Rust for experienced developers. My experience is a bit different because if if you have a complex code base and you write Rust and it compiles, you can kind of trust it. If you have a Python code that you can start, it might fail in a special way. So if the JEDI is pretty complex, so if someone does a contribution in Python or in Rust from someone that you don't know, which one can you trust more?
Yeah, I mean, I see the trap coming. Well, I mean, I would say in general, I don't trust contributions anyway, so it doesn't really matter. But like, I think you have a point that you can trust Rust contributions, but I think I also have a point that in Rust, it's kind of hard to ship a product with average or bad devs that have no experience in Rust because they'll just get nowhere. And in Python, I mean, it might be buggy and it might be bad software and like, but at least it will work somewhat and maybe it crashes from time to time, but people don't care. It's software, you know. Yeah. There's one. Oh,
Yeah. So how easy is to use Rust as an extension from Python? You showed the other way around, but it will be more interesting.
It's probably pretty easy. I haven't used it personally. That's why I didn't show it. Like, what's definitely possible since Rust works great with, like, interacts great with C, you can just use CFFI and just use kind of the C stuff. But then there's also, is it called Py03 or Pyodide? I'm not sure. It's like, there's a pretty good way to interact with it, I think. But one of the issues is going to be that like Python's reference counted and Rust has like lifetimes at its core. So you'll have to structure your code kind of in that manner. But you'll just wrap Rust objects and you write a small interface. So that's very possible. I don't think it's harder than C. It's kind of the same difficulty. And maybe one more thing, and I think that's also kind of a great application where I will see Rust coming in as well, like libraries like NumPy or SciPy. They're all written in C, and like they could just be written in Rust. So I think that's kind of the way how the languages will interact together. Yeah.
So in recent years, I've read a lot about both Python and Rust kind of pushing into the embedded space, like I'd say Arduino class hardware. If I don't really know either one of them for embedded development, do you have like a suggestion with which one to start, or is there like a clear winner? Or
I would say there's a clear winner there, and that's Rust, and not for the reason that I don't like Python there, but the issue is that like Python needs a runtime, and you cannot compile Python. And so like Python will be running on like certain boards, but not on all boards. And Rust will run on pretty much anything that C runs on. Sometimes it's kind of annoying to get it to work, but like, but I mean, if you use it, like most of those projects are like for fun anyway, so just use whatever you like. Like, it doesn't really matter, but like Rust is the winner in the sense of it will be part of the industry. Python I don't think Python will be part of the industry in that space. It uses a lot of power and like, it's just too slow and too memory hungry. Yep. There's one more there.
Okay, so actually no question, but a comment to this question, how easy it is to interface with Python. So I have a little bit experience with this Py03 thingy.
Yeah.
And so as you said, it's very easy. In some cases, you even have a macro where you just can turn a Rust function directly into a Python function inside the module.
Okay,
So
that sounds like it's great.
It's
Yeah.
really great in my experience. Okay, to that, then before there was another question about the security. So I'd say Rust is not a secure language. It is a memory safe and threat safe language, but it suffers all the other risks other programming languages have as well. But with respect to this, I read that I think 1 month ago, the Rust Foundation got funding for a security group. So they're really addressing this issue now.
Well, I don't know anything about this particular case. I don't really follow Rust, the language. I follow the release notes, but I don't like read that kind of news. I would just say, like, when you say Rust is not a secure language, I would kind of counter that with, yes, it's memory secure, and obviously that's kind of part of it, but it's also more secure than a lot of other languages because it doesn't suffer certain problems like null pointer exceptions or this is not my alarm clock.
Yeah, I mean, but also null pointer is memory, so this is again.
No, with
this is
null
memory
pointer
safe.
exceptions, I mean like in Python, where it is memory safe, but it will just fail at a random point, and or it will kind of inject a weird value that you in Java you can just push a null somewhere, and it's still memory safe, but like it can lead to weird behaviors. And yeah.
One more question.
Thank you. When you mentioned that Rust might be harder to test compared to Python, I guess you won't agree, but does that mean that it's less appropriate for bigger code bases where you might need to rely more on unit tests?
What did you like? I'm not sure. You like I know what you're referring to. Can you maybe clarify that? Like,
well, you mentioned that it's harder to test. I haven't worked with Rust, so I don't.
I don't think it's harder to test in an automated sense. It's not hard. Like, you can write tests and it's great. Like, Cargo is great for testing and everything. It's just that if you want to like try something and like
Quickly
change
run
this line of code and like see what it does, that kind of stuff is like kind of annoying Rust.
Okay, yeah, got it.
Yeah.
Okay, if I may ask one last question.
Yeah.
Then continuing on that topic, I've heard recently a lot of talk about Linux kernel modules being written in Rust,
Yeah.
right? So it's going towards like the more larger, complex code bases. And you also mentioned like, hey, like maybe when you get to enterprise level, large code bases and so on, it can get complicated to organize code. How do you see that future going?
Well, I mean, like, I think the kernel is a bit different than enterprise level software because it's kind of different people doing that kind of stuff. And I think kernel devs are like usually like the most capable devs, so they'll find a way. In general, one thing I didn't mention is compile times. Compile times are like kind of okay, I guess, in Rust, but they're nowhere near Go or whatever, or C. And so there's good incremental compilation, so you can work with it. As a dev, I don't have issues, but like, I think if you have like a 1 million line code base, and especially if it's just one crate, which is like a package, that's where things I think will start to slow down, and you'll have compile times of like a minute or even higher. Whereas in C or C++, it's just better. Or like languages like Go is a good example. In Go, the compile time will probably like be 10 times or 20 times faster. And that's just something, It might not be 10 times, but like it will be faster by a significant margin. And for devs, that's just very nice. One thing I didn't mention is like what's cool about Rust though, especially compared to Python, tests will run really quick. So I will compile like, especially in release mode, I will run like 1,000 tests in like 0.1 second. But it will like compile for like 5 seconds. So it's like as fast as Python at that point. But I can run all the tests all the time, which I usually don't do. I use PyTest and then I run like 5 tests or 1 test and that's it. Yeah.
Okay. Thank you very much, Dave. Thank you.